A wonderful day. Today we'll be talking about managing Flutter's data, an application's data locally in a Flutter application. So it's all about data persistence locally. For those of you who don't know who I am, my name is Sakina Abbas. I am the co-founder and CEO of Reactory Private Limited. We are a software house and we specialize in the development of web applications and mobile applications. I initially started off as a native Android developer, but then eventually transitioned to Flutter development. So that's what I'm currently doing. I am currently leading the DevOps and Flutter development at my company. I am also a core member of Flutter Project Pakistan. So you may have heard, or you may have rather seen me in a lot of events and a lot of talks recently. And I also very recently joined Google Developer Space Singapore as a Women in Tech speaker. So that's all about me. Now, before we get started, let's do a quick exercise, right? What I want you guys to do is take out your phones. If you're actually watching this event right now on your phones, then perhaps pick up a secondary device, a tablet, or another separate mobile phone that would do. Now, these are three of the applications that I'm sure every one of you has used at least once in their lives, right? So either open up LinkedIn, Twitter, or Facebook, any application on your phone, and just use it, right? Swipe screens or whatever. Now, after you've done that, close the application from your phone that you were just currently testing it out on, and make sure that you turn off the Wi-Fi or the mobile data on that device, right? Have you turned off your Wi-Fi connectivity? Your phone is completely devoid of internet connection? Awesome. Now reopen the application that you had just opened, be it LinkedIn, Twitter, or Facebook. Just reopen it in an offline state and see what you can see on the screen. It's probably that you can still see part of the data or some of the data, and some of you might even be noticing messages like, oops, the internet connection was not found, you're disconnected, right? Now, that's basically what we're going to talk about today. We're going to see how applications still work despite not having internet connection. All right. Now, these are some of the screenshots from the experiment that you might have just conducted on your own devices. On Twitter, I was still able to see previous tweets. Okay. Although we had limited functionality, I could still see tweets there, right? Similarly, on the LinkedIn platform, I could see part of the content. Some of the content was not rendering, but I could see at least some textual content. And also on the LinkedIn app, I could see that there is no internet connection, right? So basically, the thing that we noticed is that even in an offline state, part of the data is still available, although we have limited functionality. So you can't really message someone or you can't really swipe to refresh your content or whatever, right? So maybe that is due to some caching mechanism that these applications are performing. Let's see. Another famous example of this happening is WhatsApp and the Google Keep app. In WhatsApp, while you have the internet connectivity, you can send messages to others, you can get messages from others, and basically you can do anything, right? Similarly, Google Keep allows you to save all of your notes to cloud so that they're accessible even when you open that app from another device or from maybe perhaps a desktop, right? Now, the good thing about these two applications that I'm sure 95% of you may have noticed is that in WhatsApp, when your Wi-Fi is down, when your internet connectivity is off, you can still see the list of conversations that you've had. In fact, you can even see each individual conversation. You can read all of them, and you can basically just scroll among different messages, right? Similarly, in the Google Keep app, that's completely offline. If you want to take a new note, even if your cell phone doesn't have internet connectivity, you can still take down notes. You can still organize your lists, etc., etc. Right? So some of the applications work completely offline. Some of the applications work offline plus online. So there's a different mix of internet connectivity and data management that applications take into consideration. So basically, this leads us to the fact that localizing data helps us to improve the user experience. Okay, how does that enable us? Because customers or users, they can use those applications without really having to connect to the internet all the time. So they don't have to be 100% reliant or dependent on internet. Two, the caching mechanism, it really preserves the beauty or the aesthetics of an application. So even if you don't have internet connectivity, it will still show you partial data, right? So it helps with the user experience. It makes the applications performant in the sense that it doesn't give the impression that you need to have an internet connection and a really good one in order to use this app properly. So it makes the application performant in terms of user experience, user interface, all that different stuff. And then lastly, who doesn't like using offline apps? Now, let's walk through the different techniques of how you can localize data management in Flutter. Starting off with the very first and the very simplest of the techniques, which is storing key value pairs with shared preferences. Now, what is shared preferences? Shared preferences is a mechanism that enables you to store key value pairs on the disk, right? So yeah, in layman terms, you could say that it's a cache management system. There's a file in which when you basically store each key value pair, then on the back end on the disk that you cannot really have access to, that you cannot see, it's being stored in an XML format. Okay, so it uses the key value pair strategy, and it's very useful for storing small amounts of primitive data, such as your application settings, like do I want the notifications on? Do I want the notifications off? What time do I want the daily reminders? Am I logged into the application? Or, just basically the simplest of the data that you can store. It doesn't have to be bulky. It can be very small, such as even a user's name, right? So you can get all creative with what kind of data you can store with shared preferences. Now, uh, Flutter actually provides a plugin for shared preferences. Okay, it enables you to localize data in the sense that it enables you to store your data or some chunks of your data into your disk using shared preferences in both Android and iOS. So it's a single plugin, and just by importing that and writing two lines of code, you can basically persist your data with shared preferences. Now, the data types that it supports is integer, double, string, Boolean, and a string list, right? Now, even though it supports these primitive data types, you can still store images and even custom objects in shared preferences. How we'll do that, let's look into that. But first, let's look into a very simple approach of storing the simplest data, an integer, in shared preferences. Now, this is a piece of code from an application that I coded about a month ago. I basically designed, or rather, I developed a game. It was a bubble popping game, and it had infinite levels. Okay. Now, I wasn't using any online or any external databases for storing any of the information. Rather, I was storing that in shared preferences. So in order to do that, what you need to do is first you need to, obviously, aside from including that in your pubspec.yaml as your dependency, aside from doing that, you need to first make this call. You need to get the instance of your shared preferences, and that returns a future, right? Which is why we have the await keyword over here, right? Now, once you've written this code, meaning you've basically initialized your shared preferences, then you can do however many tasks that you want to do with your shared preferences. So let's say you want to store an integer in your shared preferences. This is the line of code that's responsible for doing this. The set int is a function, right? It's a method, and the key, it can be anything. I have set it to basically level, right? So that when I'm retrieving the level path for reading it, I know that I have to get the value that is paired with the key level, right? So the first parameter is the key itself. And the second parameter is the value itself. And here I have passed my value, which is current level +1. That's it. With these 2 lines of code, you have stored your level locally in shared preferences. And now you don't really have to query here and there. You can access it in your application whenever and wherever you want. That's the beauty of it. Now, you have stored it. Now you want to retrieve it for displaying purposes or any other purposes. Again, if you're doing that in a separate file, in a separate screen, then you would have to initialize your shared preferences as again. Yes. But in order to avoid initializing shared preferences again and again and again, what you can do is you can actually create a custom singleton class and initialize it inside that. So you just have to initialize your shared preferences once. That is when your application is starting up. And then following that, you just have to use the set or the get methods in order to store or retrieve your data, right? Now, here, if we want to retrieve the data, what we would do is that after initializing it, we were to use the getInt method and pass the key to it, right? Now, initially, I stored a value that was paired with this key level, which is why I have passed level. I want the value associated with this key. And if it's not null, I will get that value. But if it's null, then I'll get 0. Okay, that's it. That's the simplest thing. Now, similar to this method, you have set string, get string, set bool, get bool, and all of the other data types that I just told you about a little bit earlier. Now, if you were to store a custom object using shared preferences, how could you do that? Well, it's pretty simple. You would basically convert your custom object to a string. And the simplest way to do that is using JSON encoder, which takes a map object, okay, and it basically translates it to, or rather converts it to a string. So once you've done that using JSON encoder, you get a string of your custom object. And then using the setString method, you can simply store it in your local shared preferences. And similarly, when you want to retrieve a custom object, you will use the getString method, pass the key, use the getString method. You will get your custom object. Again, it's currently encoded as a string, so you need to decode it. Again, if it's not null, use the JSON decoder this time, and you can convert your string into a map itself. Pretty cool, right? Now, the second technique is storing data in files. I'm sure if if you're currently studying in university or you've already studied from university, I'm sure every one of you must have encountered filing at least once in any course that you guys have studied, right? This is exactly that, filing. Now, with files, what type of data can you store locally? Again, similar to shared preferences that we just saw, you can store strings, you can store images, you can store objects in a local file. Okay, but this filing is the use case of this is basically for storing modular or file-wise data, right? Because in shared preferences, you could only store key value paired, okay? If your use case is such that there is no scenario for a key value data, then you wouldn't be using shared preferences because, like I said, it's just used for basic smaller chunks of data, not large data. For a much larger data, you were to use filing. And a good example of this is the Google Keeps application. Since every node is a separate entity in itself, you actually, on the back end, actually separate files are being created for each of the nodes that you create in this application, right? So for strings, it's pretty straightforward. You can directly store them into a file. You can write them to a file. But for objects, you need to serialize them. Again, you need to serialize them into a string that we just saw earlier. And for retrieving the data, you again need to deserialize it, okay? But the good thing about images is over here that it can be directly saved on the disk. So that's pretty cool. I won't be delving in too deep into the syntax of filing because in comparison to the different techniques that we will be exploring in this session, filing this, or rather the scope of filing is not that much until and unless you're creating a node-based application. Okay, it has very restricted or rather specific use case. So if you're interested in doing that, you can definitely check it out. Basically, Flutter provides a file class that allows you to write to a file or modify a file or basically do any of the operations with a file. And in order to do that, there is a plugin called Path or Path Provider. Through that plugin, you need to basically get the parent location of the directory where you want your files to be stored, such that when the files have been created and your data has been shifted locally to your disk, even when you're not using an application, and if you're feeling too curious about where your files are being stored, then you can always go into your file manager on Android, at least. I don't think iOS allows you to do that. And you can check out the separate files that were actually built, right? So it's just a two ingredient process, and it's not that difficult. It's pretty easy. You can definitely check it out if you're interested in filing in Flutter. Now, but the biggest caveat or the biggest disadvantage of data persistence with files is that it's not structured. Yes, it's modular, but it's not structured in the sense that if you were to query something that, okay, I want all of those notes that were created on a specific date, right? You cannot query that with files because each file is a separate entity and there is no query mechanism interlinking the file system and your application, right? So it's not structured. If you want to store structured data and you have lots of data that you need to store on your local disk, then you have to use SQFLite. Yes, SQFLite is a plugin for SQLite, which is an SQL database. And this is very handy and in fact very popular when you want to store large and complex data in a structured format locally into your phones or locally into your devices. Now, what is SQFLite? Like I said, it's an SQLite plugin for Flutter. Okay. And what is SQLite itself? For those of you who are very beginners and who don't really know that much about databases, SQLite is an embeddable relational database management system. By the word embeddable, I mean that this database, it's not on the cloud, it's not anywhere else. It's rather embedded into your application, right? You cannot even see the contents of this, but if you were to uninstall your application and then reinstall it, then the database would have been refreshed. Okay, so that's what embeddable means. It's embedded into your application. Now, this plugin, it allows you to create databases, it allows you to define or create tables, and it allows you to perform different CRUD operations such as creating a record, reading a record, updating records, deleting records, these things, right? And like I told you earlier, SQFLite is used to persist larger and more complex data in a more structured format in your local disk. So this is how it works. You first create a database using the SQFLite plugin. Inside that database, you then create your different tables. And how you do that, you create a table by passing the different columns that you need. For instance, in this example, we have this serial number or something. Then we have the name. Then we have the phone number. And then we have the city. These are the columns. Once you've created your table, you can write to your table by storing the data over there, and it's stored there in a very structured format. Each record is a single row. And when you want to fetch records, you can use the read operations in order to fetch records as per your query. Now, in order to do this in Flutter, here are the ingredients that you will need. First of all, you will need the SQFLite dependency from pub.dev. You will also need the path dependency from hub.dev. This is, again, in order to provide the path for everything and for basically initializing your database and your table. Then you will need two classes. The first class will be a helper class database provider. Inside this will be all your database related operations, or rather functions. We'll be looking into the live code right now. Then you need your model class. This will be the class of the objects that you want to store locally in this database. Okay. And then lastly, it's optional whether you want to use any custom state management technique. You can even start off with the basic set state, but if you're working on a more advanced level, block provider, whatever suits you best, you can do. Now, after having a look at the ingredients, the method is that the core method, after obviously incorporating the dependencies that I listed earlier, the core thing is the database provider class, okay? Because this is the actual class that will be bridging your application and the database, right? So the first thing inside the database provider class that you need to do is to create several constants. These will be of type string, and these are for your database. It'll be the name of your database, the name of the table that you want to create, the different column names that you need to have, etc. Then you need to create a private constructor inside your database provider class so that your database provider is a singleton class. For those of you who don't know what singleton means, it means that you just initialize it once and then you can use it anywhere throughout your application, okay? Now, thirdly, you need to have a function that is responsible for initializing the database, or if it doesn't exist, then it should create one. And then lastly, you can have as many functions as you want for performing CRUD operations. Let's quickly delve into the code. I will be quickly switching my screens because currently I'm sharing just one single tab. So just bear with me while I switch my screens, right? Okay, I already have some demo code, in fact, a rather demo project created for you guys. I have clicked on playing it so that you guys can see it in action. But while the project is being built, let me quickly walk you through the code. So this project is basically a dream journal. It's an offline application that allows you to create different notes or dreams, whatever dreams you had, and you can quickly journal them. Okay. So as you can see, we have the application loaded over here, and we can see that there is a list of dream journal entries that we can see over here. Now, if I were to click on this, let's say, then it takes me to another screen, which is the form screen. And here I can update or edit my dream. Okay, so it's showing me all of this data. And if I were to update it, it has updated this over here. Okay, similarly, if I want to delete any dream, I can click on this and that's it. Okay, all right. Now, okay, walking you through the code, it's basically working in the sense that I have a basic dream class in which the properties are ID, title, details, uh, the toMap function and the fromMap function. The toMap function is responsible for basically setting the different properties. This is for when I want to create a dream journal entry or I want to edit a dream journal entry. And the from map is the function that is responsible for the deserialization. That is when I'm getting entries from the database. So what's happening? All right. Now, right. Again, now this is the database provider class. This is the helper class that I was telling you earlier about. I have a bunch of constant strings over here, as you can see. So my table's name is dream, and my columns are ID, title, and details. Now, this is the part where you are handling the private constructor to make this class a singleton. If you want to create a private constructor, you do that using underscore and parentheses. Now, this variable is basically for getting access to this class, and this is a private variable, meaning that you can use it only inside this class and not from anywhere outside. So this is to ensure global access to this file, to this specific helper class. Now, we have this get database method. Okay, it's a getter, and what it does is that it fetches this instance of the database. Again, singleton concepts. Now, the actual essence is this. Create database is the first function that you need to write. Over here, what you would do is that you first get the database path using the path dependency. And then after that, there is this function that you code, which is open database. What this function does is that you first give it the path where you want this database to be created. This is a method that creates the provided database in the provided path. All right, this is the path. This is the name of the database. You can create it in constants. This is the version. Version is responsible for when you want to make structural changes to your database. So let's say if in the future you were to add another column or perhaps a separate table, then you were to change this version level, okay? That's what it's used to keep track of. Then we have an onCreate method. The onCreate method is responsible for basically it checks whether this database exists. If it doesn't exist, then it creates it, and then on create, it creates the table that you provided. So over here, we have this table we're creating. The table's name is table. Oh, sorry, the table's name is dream that we just saw earlier in our constants. And we're basically creating the table with the following columns. Our ID is of type integer, and it is the primary key in this case. Yes, whenever you're creating a table, you need to provide a primary key, basic database concepts. If you don't know, Google. Then you have another column for title, the title of the dream, and then the details of the dream. And they're both string. Strings are basically referred to as text in SQL language. Okay, next we have a function for get dreams. What this does is that it gets the database instance and then it performs a query. So what this is doing is that it will query on our dream table and it will fetch these details, the column ID, column title, column details, and it will order it in descending order. In descending order of the ID itself. So the latest entries will be shown first. And then once it has retrieved all that data in dreams, it's all basic coding for how you want to display it. For the sake of this project, I am using block state management. I won't be delving in too deep as to what things are being handled where, but that's how we're basically displaying data. When we get it from our queries, we're basically adding it to dream list. And then after that, it's all block stuff. Okay. Now, this is the insert function. Oh, I just remembered I didn't show you how we're inserting items. So I had a dream. It was a test dream. Okay. Submit. And we've noticed that it's appearing over here at the bottom. Now, you were to ask me that, okay, Sakina, you just told us that all the dream entries, they're being displayed in the descending order. So why is this still appearing at the bottom? Actually, inside my block class, I have for the for the new entry, I am using the add method. So what the add method is doing, that even though our current list looks like this, that we have this dream entry as the first entry and this dream entry as the last entry. So what this add method did was that it appended this new entry at the end. Okay, so if I were to fix that, I would obviously use insert instead of add. Insert 0 this. Now I need to cold restart it because I did notice that some of the data, it wasn't being synchronized with hot reload or hot restart. So just to ensure that things are working smoothly, I have performed a cold restart. Again, don't concern yourself with all of this. If you don't know what block state management is, don't worry. You can even test out SQFLite using the simple set state, right? Anyway, while it's building, let's look at what the insert function is doing. So what the insert function does is that it takes an object of class dream. Okay, it gets an instance of the database object or the class of this database, and then it uses the insert function in order to add this new dream inside this table. Okay, now over here, the syntax is such that you first pass the table, in which table you want to create this entry, and then you pass your object that you want to basically store in your database. So over here is where we're basically using the toMap function, right? And then when it's inserted it successfully, it returns a dream. It inserts the ID of this object so that you can basically use that later on. Also, another thing that I forgot to mention was that you can definitely generate random IDs as per your convenience or as per your use case. But in case you're not doing that, in case you haven't even provided any code for ID, because over here, as you can see in my form class, right over here, where's the submit button? Right over here, I'm just passing the title and the details in my dream object. There is no ID. So what SQFLite does is that even if you don't provide a custom implementation for your primary key, it auto-generates it using 1 and then increments it by 1 by 1 by 1. So 1, 2, 3, 4, and so on and so forth. Okay. And another thing that I'm sure many of you might be having a question for is that you deleted this dream entry. Why is it still appearing over here? And the reason is that for some reason, the ID at that time was null. So obviously, when the ID was null, it didn't perform the update, or rather, it didn't perform the delete operation properly. So, but right now, we just check the ID is 1 somehow magically. Maybe my update function is a little bit messy. Anyway, if we were to close this right now, I mean, delete it right now, it's deleted. And I promise if I cold restart it again, this entry will not be there anymore. Anyway, so that's all about the insert function. Now we have the delete function. What this is doing is that, again, getting the instance for the database class and using the delete method this time. Again, you pass in the table's name, which table you want to delete. And the syntax is such that you basically delete where the ID is equal to the specific ID. Okay, you do that and it will delete it. And then there we have the update function. What the update function does is that it again fetches the instance for the database class. And it this time uses the update method and it updates the row, the record, where the ID, where the past ID is equal to that ID. And it, again, we're passing the new dream object this time. So if you look over here in the submit button, sorry, in the update button, what we're doing is that we're taking the dream object. So whatever changes I'm making in the form, those will be updated. Okay, those fields will be updated. And when I call the database provider.db.update, this is basically the call I'm making to my provider class, my helper class, I will pass in this new dream object, and I think I have figured out why it was being messy. I had to pass dream, not widget.dream, because widget.dream is the previous instance, and this dream is the new object, right? Um, anyway, so all right. I think we are running a little short on time. Otherwise, I would have showed you different queries on this. But I will be taking questions right now. If you have absolutely any questions, please feel free to let me know. And if you're more interested in this project, or if you're more interested in finding out about the nitty gritties of how SQFLite works in Flutter, then by all means, ping me on LinkedIn. I will definitely help you out.
Sakina, we actually do have some time. So if you want to go over some other points, feel free to
Okay.
do so. We do have some questions, but
All right.
I'll save them for the end.
All right. Perfect. That sounds great. So let's quickly perform some interesting operation. Okay. So over here, what you can see is simply a list of dream entries, right? Now let's imagine that you have a search field where you type any keyword, and you can basically fetch dreams that contain that keyword in that title. Okay, so let's do that. So for that, what we need to do is, let me just quickly edit the UI. Okay, converting this to children. Right, what do we need now? Some padding. Manhattan text. Even.
Hey, Sakina. So I think we've lost Sakina. So we'll probably wait a couple more minutes to make sure that she can join back.
Yeah, she dropped.
So let's just wait a couple more minutes.
Hello, am I live now?
Yes.
I'm so sorry. This doesn't usually happen, and this is literally the first time that this has happened. Um,
Yeah, no issues. Things happen.
okay, let me just carry on.
Yeah.
Okay, so if whatever you missed, basically I have created this text field. So over here, you can basically type your keywords, and you can check out. Basically, you can get the dreams, those dream entries, which contain that specific keyword in their titles. Okay, so I have created a text field for that, and I have also created a function for that. Okay, I have created this new function called get dreams by name, passing a string keyword, and these are the two lines of code that are new. So what it's doing is that it's looking up at the this title column, and it's checking which entry contains this specific keyword inside inside its title. Okay, missed out a dollar sign over here. All right, so it's all good to go now, and yes, lastly, I need to obviously write that calling over here. So how I would do that is just copy this line of code from here. It's using get dreams, so get dreams by name, and the keyword is input. And hopefully this should do the trick, performing a cold restart just to ensure that everything has been set up properly. And let's see how well it works. It can take a couple of minutes sometimes. Usually when the PC knows that you're in a hurry and there are hundreds of people watching you, you are bound to run into some trouble or another. So let's just wait, and we're almost done. Almost there. Anytime now. Awesome. Okay. Now we have a bunch of different dream entries over here. Let's search for Pokemon. And see, we have this over here. We have the Pokemon entry over here. And now if I were to search for, we have this dream entry. So this was all about local data persistence. Store simple key value data in your Flutter application locally, then you have to use shared preferences. Okay, it's for storing simple data, which are of primitive data types, and they're smaller chunks of data. They're not large records. They're not large WhatsApp conversations. They're not large files. They're simple settings, such as the user's name for displaying on the app bar, perhaps the user's picture for caching it, and basically primitive data. All right. Now, secondly, if you want to store modular data, such as in a Google Keeps app, where your application is node-based application, each object is a separate entity in itself and needs its separate presence, then you were to consider filing. Or if now, thirdly, if you want to use larger data, more complex data, and you need to provide some structure to it so that you can perform some query operations, you can perform some filtering operations. If you want to perform different CRUD operations, then you have to use the SQFLite. approach. So these are the different techniques that are how you can persist data locally in your Flutter application. And if you have any questions, please feel free to let me know. And again, I'm so sorry for the internet mishap.
Yeah, nothing to worry about. So we actually do have a couple of questions. And the first question is by Mohammad Fizan. The question is, what happens sorry, the question is, what happens if a low performance device doesn't have much storage left? How data localization will work and how is it optimized?
Okay, that's actually a pretty good question. In that case, first of all, you need to absolutely disregard filing, okay? But if in case your application is already using filing, okay, and you don't have time or the effort or the energy left to migrate to a different data persistence mechanism, then what you would do is that then it's actually the user's headache, okay? He has to make space on his phone, first of all.
Mhm.
Or secondly, if you want to if you want to ensure that your application is as performant as possible and you need to optimize your data persistence, then you could consider different approaches. Maybe you could consider shared preferences. Okay, you could store half data on an online cloud database. You could store half of the data locally. So it's all about architecture designing. It's all about how you want to design the application to make it as performant as possible in terms of speed as well as storage. So it's all about architecture design.
Okay, makes sense, makes sense. The next question is by Shiraz Khan. And the question is, how can we prioritize the Flutter than React Native? So I
Okay,
think the question
so
is, what makes Flutter better than React Native? I think that's the
yeah,
actual question.
yeah, okay. So the thing is that Flutter is actually the best part about Flutter is that it comes pre-packed with these widgets, okay, जिनकी behind the scenes की coding is being happening on the native components, the native UI components of the Android and the iOS framework.
Mhm.
React Native, on the other hand, uses web technologies, web stack, and it uses JavaScript to bridge the application, the cross-platform application, with your native components of the platform that you're running this application on, right? So in React Native, there's a little bit of performance issues, but in Flutter, it works as if it were a native application. So there is this thing that Flutter uses native components itself. So the performance is better. And in React Native, the performance is relatively lower. So that's one thing. And for others, I could definitely go on and on, but I'm sure other people also have to speak.
Yeah,
So yeah.
makes sense, makes sense. I think the third question is sort of related to the previous one. The question is, how can we use semantic UI in this? So if I recall correctly, semantic UI is UI library for JavaScript and React. So I guess the question is, are there any UI libraries available? And if there's any interop between existing JavaScript and front-end libraries?
Okay, so the best way that I could probably answer is that because again, I'm not a web developer, so I'm not that aware of those terminologies. The thing is that yes, to some extent you can. Be in if let's suppose let's just consider a web view. Okay, so in web view you can actually inject your custom JavaScript code, and with web view actually you can actually render the native web-ish code. I'm sorry, I'm not a web developer, so I don't know the proper terminologies over there. But yes, there are some workarounds that can allow you to make that happen. So yeah.
Okay, makes sense. Our final question is by Javeed Ishaq. The question is, how can we sync? I think the question is, how can we sync local database with remote database in Flutter?
Yeah, that's actually a pretty good question. So what you can do is that for any data that you're getting from, let's say, a cloud-based database, right? When you have retrieved the data from there, now it's all about architecture designing. Okay, it's all up to you how you want to design your application. For instance, you could perform routine backups in that sense, what you would do is that maybe you want to back up the data in your local database, meaning the embedded database, let's say once a week, right? That is one approach. The second approach is that maybe when you're fetching the data from the cloud-based database, and you can temporarily store it in the database. And let's say if the user gets disconnected from the internet, like I just did, so you can fetch that data from the embedded database, the SQFLite database that you have just shifted it to. So it's all about designing principles and designing practices. There are routine backups, there are instant caching, and there are actually even plugins for web-based caching itself that I didn't delve into. So there are different approaches available, and you can feel free to explore whichever suits your use case.
Perfect, perfect. I think that's it. Thank you so much for your time, Sakina. Your talk was amazing. Even I learned something today. And
Thank you. Thank you for having me. It was wonderful.
thank you so much.